Hello. Okay, so welcome back, and we are doing continuous random variable today. So without a further ado, let's get started. So for continuous random variable, the area under the graph represents probability. Okay, so this should be enough to teach you the entire continuous probability. My job ends here. Thank you all for no. Okay, sorry. Okay, let's start off by looking at probability density function. So these are some following rules for probability density function. The area of probability density function must always add up to 1. So this area under the graph over here, let's say that this is our graph, and this area under here must always add up to 1 because probability always add up to 1. That's first rule that needs to be remembered anyhow. Now the second rule, a function is considered probability density function if and only if f of x is greater than or equal to 0. Now, say that you have this function over here, right? Like so. And this is the area encased. Why is this wrong? Can this represent probability? No. Why is that? Well, that's because can probability ever be negative? Because simply, if the graph or the function is below x-axis, that area is considered to be negative area, right? And area represents what? Area represents probability. So probability is always positive, and hence the function must be greater than or equal to 0. It can be 0, function can be equal to 0 because, well, probability can also be equal to 0. That's perfectly fine. But as soon as the graph or function or the area encased is below the x-axis, that is considered negative area and hence negative probability, and negative probability doesn't exist. Okay, I hope that made sense. So how do I write this probability of a less than or equal to x less than or equal to b? Well, what is probability in this chapter? It's area under the graph. And how do I calculate area under the graph? Integral. And what are our endpoints? What are our terminals? It's from a to b, f of x, and don't forget the dx. Dx is very important, or else you lose 1 mark. Okay. Based on the previous dot point, what would be the result of probability of x equal to a? Okay, interesting question. So let's say you had this graph over here, like so, and I ask you to find me the probability right over here. Can you do that? Now, let's try. So if I want to just find probability that x equals to a, that means our starting point is a and our ending point is a as well. F of x dx. Now, can you see something fishy over here? This, if you simplify it, would just equal to what? 0. Meaning that probability at particular point in this chapter is just going to be 0. Now, why is that? Because area is what? Thin slices of rectangles added up together represents area. Now, for thin slices to occur, you need 2 terminals, right? And the terminal has to be different. If the terminal is the same, then how can thin slices of rectangle form, right? So that's the intuitive understanding that if they want probability at x equals to a particular point in continuous probability, then it's going to be equal to 0. Okay. Does your previous finding convey anything else? If so, what does it convey? Okay, this is a good question. Now, I'm going to use this to continue. If I were to find probability of a less than or equal to x less than or equal to b, I would write what? I would write this integral over here, right? Now what happens if I want to find probability of a less than x less than or equals to b? What would I write then? It would still be the same as a to b, f of x dx. No difference whatsoever. Now why is that? Well, because it doesn't matter if I include a or not, right? If I include a, like here I showed you the example over here, even if I include a, the area at x equals to a is still going to be 0. Same with b. The area at x equals to b is going to be 0. So even if we include or doesn't include, it does not matter. So it does convey something, which is probability of a less than or equal to x less than or equal to b is the same as probability of a less than or equal to x less than or equal to b, which is the same as probability of a less than or equals to x less than or equal to b, which is also the same as probability of a less than x less than b. Right? I hope that made sense, because it does not matter if you include the endpoints or not, right? Because integral is going to calculate the area between those endpoints. It cannot calculate the area at the specific endpoint because that is just going to be 0, as we saw in this example over here, that at a it's going to be 0 and at b it's going to be 0. So it's irrelevant. Okay, I hope that made sense. Let's move on. So we have our first question. Alright, so we have this f of x where k is positive real numbers. When you say this, it's basically 0 to infinity. It does not include 0. Okay. And x is a random continuous variable. Okay, good. So we have already defined our variable in the question, so that's fine. We don't have to define the variable anymore. Okay. Given that f of x is a probability density function, find the value of a in terms of k. Yep. Pretty strong question to start off with, I know. Now, one thing, this question is purely based around property over here. That's the hint. If you want to try this question, pause the video and do so. I'm going to be going through solution now. Okay. So we know that for it to be, a probability density function, the graph has to be above the x-axis. So the area that is encased must be above the x-axis, so that it represents positive probability which exists, right? Okay. Now, one other thing that also matters here is the x-intercept. We know that it's just going to be 0 and a. So all we have to really do is just find a in terms of k, which is not going to be that hard of a task given the equation already. Now, why is that we stop at the x-intercept? If I were to keep going like this, right, you can see that this is negative area coming up, correct? And there is no negative area because there is no negative probability. So that's why most of the time in probability density, not even most, all the time in probability density function, the function that they give you in the exam or the SAC, they are going to stop mostly at x-intercept. Okay? Alright, very good. So let's calculate the x-intercept of this graph. So minus kx squared plus 5x equals to 0. Taking out x as common, minus kx plus 5 equals to 0. So meaning that x is equal to 0 or x is equals to 5 on k. Now x and a same thing because they are both x-intercept anyway. So a is equals to 5 on k. Okay, very good. Now let's move on. Let's move on to the next question. So hence find the value of k. Okay, so what are the properties that we use here? There's only one, which is that area under the graph of a probability density function always must add up to 1. We know the n terminals, don't we? What are our n terminals? That's correct. It's going to be 0 and a, which is going to be what? 5 over k. Okay. So it's going to be an integral from 0 to 5 on k f of x dx equal to 1. Now if you simplify and solve this on CAS, this will give you k equals to plus or minus 5 root 30 on 6. Now, is this our answer? Do I leave my answer like this? No. Look up. K is a positive constant. So we have to mention that k belongs to R plus. So since k belongs to R plus, k is going to be positive 5 root 30 over 6. Now this is our answer. Okay? Always check the condition of the variable or the domain of the variable. You should always try to check it and then give the answer accordingly, because it's a big trip up that most of the students fall into. It's a trap and a lot of people fall into that, but we don't want to do that. Okay, let's move on to the next question. Alright, lifespan of a battery can be modeled by probability density function f, where t is time in days. Again, our variable, continuous random variable, is already defined, so that's pretty good. If it wasn't defined, you must define it and then continue. Okay, alright, very good. Now show that k is equal to 5. Now here they say show, so we need to show working out, meaning that we have to do this question by hand. This is an exam 1 question, so we have to do it by hand, and I'll show you how to do it. So this is like a truncus. Now if I were to sketch a truncus, it will look like this. So like that, there's an asymptote, and like this. You can see that this truncus just keeps going on forever, and what we have to do is to show that k equals to 5. Now we are given our domain here, t is greater than or equal to 0. Now let's construct an integral first. So it's going to be from 0 to where? Remember that truncus just keeps going on and on and on and on forever, right? So it will be from 0 to infinity, k over t plus 5 squared dt. And this is what we need to integrate. And of course, don't forget that this integral equal to 1 because it's a probability density function. Okay, how do I integrate this? Yeah, good question. So what I'm going to do is use limits. So limit a approaches to positive infinity. I'll explain the limit, just give me a second. From 0 to a, k over t plus 5 whole squared dt equals to 1. Now this is the same as writing this integral over here. So let me explain this a bit. What I've done here is I have replaced infinity with a variable a, and what I've done is I've just given a limit that a is going to positive infinity. Why is that? Why is it positive infinity? Because let's guess the truncus again. So this is going to be our side that we are going to focus on, and our domain says that it's going to be greater than or equal to 0, so it's going to be like that. So as you can see that it's going to positive infinity, right? So that's why I wrote a approaches to positive infinity. So as a approaches to positive infinity, we have to evaluate the integral that is under here. It's the same exact thing. There has been no difference. So let's evaluate this. I'll show you my steps as I go along, and I'll try and explain. Alright, let's begin. So limit of a belongs to infinity, positive infinity, is going to be k integral of 0 to a 1 on t plus 5 whole squared dt, and that whole thing is equal to 1. Now always remember that you need to include the whole thing. You must write limit whenever you're using this, so you must write limit, or else it's incorrect mathematical notation, and they might, they will probably cut marks off for that as well. So always make sure you write, right things and not incorrect and incomplete things. Okay, so now I'm going to integrate this. So it's going to be limit of a approaching to infinity, positive infinity, sorry, k, and this is just going to become -1 on t plus 5. Now how to integrate 1 over a polynomial? It's in your formula sheet, so just be on the lookout for that. From 0 to a is equal to 1. So limit of a approaching to infinity, positive infinity, is going to be k to -1 on a plus 5 minus 1 on 5. I'm just substituting 0 into t and a into t as well, right? Okay, and all of that has to equal to 1. Do not forget that. So this will become limit a approaches to infinity positive, and this would be k of -1 on a plus 5 plus 1 over 5, and this is equal to 1 again. Now what I'm going to do is I'm going to split this limit up. So limit of a approaches to infinity, positive infinity, is going to be from -k on a plus 5. This is one limit. Now plus limit of a approaching to positive infinity, or 1 on 5, and this has to equal to 1. Now, oh sorry, it's not going to be 1, it's going to be k, because well, I had to multiply k by this as well as that. So yeah, okay, that was a slight silly mistake. So yep, alright. Now let's focus on this fraction over here. So limit of a approaches to positive infinity, -k over a plus 5. Now what do you think this this limit will evaluate to? What's our final answer if I were to evaluate this limit? It's going to be just 0. How is that 0, you ask? Very good question. Okay, I'll explain. So let's say that I have to put a as a really big number. So k, -k on 1 with like a lot of 0 plus 5, and where k is a constant, like a number. Let's say that this is going to be like what, 1. This is going to be 1. Now if I were to evaluate this integral, you'll realize that your answer would be -0.0000000, a lot of zeros before you get something number. So as a gets bigger and bigger, this whole fraction is just going to approach 0. Does that make sense? Does it make sense? Okay. No? Okay. If I were to just, okay, I'll explain again. So if I were to just, put a really big number instead of a, as you can see, that it's just going to be a lot of zeros first in decimal places, and then it's going to be 0.1, 2, whatever it is. And as I keep increasing the amount of zeros and make a bigger and bigger, the amount of zeros before, this zeros, the amount of zero here will just keep increasing. And this means that eventually, as a gets infinitely big, this fraction is going to approach 0. Okay, I hope that made sense, okay? Alright, very good. So this is just going to become 0. Okay? Alright. So what about the other limit? So limit of a approaches to positive infinity, k over 5. Alright, now this is just going to say as k over 5. Why is that? Okay, good question. So let's say that you have to draw a graph of this. Now k is going to be a number, so it could be 1, 2, 3, 4, any number. So let's say I'm drawing, graph of 1 over 5, okay, for example. Now it's just going to be a straight line, y equals to k on 5, and k could be any number. So a does not have any connection with k, because it's just a straight horizontal line. No matter what the value of a is, it's still going to be a horizontal line. So that's why this limit is just going to evaluate to k on 5. Nothing else, nothing fancy. Now let's add them up together. So 0 plus k over 5. I'm just following this limit over here, which is going to be equal to 1. So k over 5 is equal to 1, meaning that k equals to 5. Okay, so that's how you prove and do these sort of integrals, which have terminals of 0 to infinity or anything to infinity. Just use limit, because limit are OP. Okay, I hope that made sense. And let's move on to question B. So find the probability that the battery lasts at least 7 days. Okay, at least 7 days, meaning that they want probability of t is greater than or equal to 7. So how do we form our integral? Our n terminals are going to be what? 7 to infinity. Why is that infinity? Because we are just given domain that t is going to be greater than or equal to 0, and there is no endpoint. So one endpoint is 0, and it just keeps going on, so infinity. So our terminal is going from 7 and infinity, and we know the value of k, so 5 over t plus 5 whole square dt. Oh, and one more reason. Say that this was an exam question. You are sitting in an exam and this was an exam question. If you for some reason don't know how to evaluate or don't know how to show that k equals to 5, it's given that k equals to 5 for a reason, so that even if you can't do this question, you can still continue using 5 and do the rest of the questions, right? So don't be that that guy who is just stuck on question 1, even though the value of k is in front of him, but he will utilize that to do the other questions. Please, if you cannot do a particular question, it's a show that question, just use the things that are given in the question, like this, k equals to 5, and use that and proceed. Don't lose the whole question, rather than it's better to always lose maybe 1 or 2 marks rather than losing the whole question. So please don't be that guy, okay? And again, we can use limits, and we have to use limits if this was an exam 1 question. So, and this is in this case because it should show that, so we have to use limits no matter what. Okay, so let's start. And so this would be, again, I'm going to allocate a as positive infinity. As a approaches to positive infinity, we have to evaluate this integral 7 to a 5 on t plus 5 whole squared dt, which is equals to, again, limit of a to positive infinity 5 integral from 7 to a 1 on t plus 5 whole squared dt, and that is going to be equals to limit of a approaching to positive infinity from 5. Now I've integrated this function, so it's going to become this after integrating. So, and these are our terminals, which is going to be limit of a approaches to infinity 5, and I'm just going to substitute the values in. Oh, sorry, I accidentally switched the terminals, I just realized. Again, okay, so it's going to be from -1 on a plus 5, a plus 5, and this is going to be -1 on 12, and this entire thing is going to equal limit of a approaches to positive infinity 5 minus 1 on a plus 5 plus 1 on 12. Now I'm going to split this limit again like I did for question A. So A approaches to positive infinity, negative 5 on A plus 5, plus limit as A approaches to infinity, positive infinity of 1 on 12. Now again, this fraction is just going to evaluate to become 0. Correct. Now again, why is that? Because let's say I substitute A as, you know, really big numbers, so 1 0 0 0 0 0 0 0 0 0 0 plus 5. Now as I increase, you know, A, this fraction is slowly just going to be 0.0000000 something something something, right? So as you can see, as I increase the A, this fraction is slowly going to approach 0. So as A tends to positive infinity, this entire fraction tends to 0. Okay. So that's why this is just going to become 0 plus, I have to 5 on 12. Again, I made the same mistake. So 0 plus 5 on 12, which is just going to be 5 on 12. So probability that t is greater than or equal to 7 is going to be 5 on 12. And that's your answer. Okay. Find the probability that the battery lasts for at least 7 days, given that it lasts for more than 4 days. So probability that battery lasts for at least 7 days, given that it lasts for 4 days. Okay. So this is same as writing probability of t greater than or equal to 7, intersecting t is greater than 4, and divide by t is greater than 4. Now what would this simplify to? Again, draw the number line OP, so 4 all the way to infinity, and 7 all the way to infinity. Now they want the intersection part of it, as you can see here. So they intersect at, you know, after this point over here, which is just going to mean that it's going to be probability of t greater than or equal to 7 divided by probability of t is greater than 4. Okay, now I'm just going to fast forward it because I've already shown you how to do integrals, you know, that approach to infinity or going to infinity. So I hope that you're fine with it now. So I'm just going to fast forward this as I do my calculation. Probability of t is greater than 4 is equals to 5 on 9, and so we have to just divide it. So probability of t greater than or equal to 7 or probability of t greater than 4 is going to equals to 5 on 12, as we found over here, divided by 5 on 9, and that's going to give us 3 on 4. So that's your answer. So this question was pretty long, I know, a lot of algebra involved, but I had to go through it so that, you know, you can understand better. Okay, let's move on to question number 3. So a superhuman loves math, and the amount of math he does in one sitting can be modeled by a probability density function where t is time in days. Oh god, okay. Bro, he's going to do maths for days. Okay, where k is a positive constant. Find the value of k. Now I'm not going to, again, you know, this is an integral involving infinity, and in methods you cannot really integrate this function, so you have to do it by cas, and I'll show you how to do it. So let me just construct the integral first. Let's do it together. So it's going to be from 0 all the way to infinity. K over t squared plus 1 dt is going to equal to 1. Now if you type this and solve for k in the cas, and I'll show you how to do it now. Alright, so let's find the value of k using cas. So first of all, I want to teach you how to define these piecewise functions on cas if you didn't know already. So press menu 1. Now type in f of x, or maybe f of t, equals to, now go to this option over here, press that, now press this option over here, and now you have your boxes to define your function. Now just type the function in, so k on t squared plus 1, and now this box that I'm on is for the domain, so t is greater than 0, and the rest is just gonna be 0. Now if you don't write any domain in this box, it's fine, it's just going to take it as elsewhere. So as you can see, it just took it as elsewhere. Now what we can do is to find the value of k. So press menu 3.1 and then menu 4.3, from 0 all the way to infinity, f of t dt equals to 1 comma k, and there you go. So our k is going to be 2 over pi. Okay, let's move on to question B. So find probability that t is greater than or equals to 3. Again, we just have to construct the integral. So 3 all the way to infinity, 2 over pi t squared plus 1, Oh, sorry, I forgot dt. Let's do it on cas now. Alright, so let's now find the probability that t is going to be greater than or equals to 3. Now, before I do that, I need to first input k equals to 2 pi in my cas calculator. So let's do that real quick. F of t, and then navigate yourself to control, press equals to. Now, press this sign over here, and I'll just type in the k equals to 2 on pi, press enter, and now as you can see, it's in our function. So let's define our function again. So menu 1 f of t equals to this function now. The reason I defined it again was because our function was previously defined in terms of k, so that's why once I substituted the value of k in, I defined it again, so now it's going to have the value of k in the function. Alright, so let's now find the probability that t is going to be greater than or equals to 3. So what you do is press menu for 3, our lower terminal is going to be 3 and upper terminal is going to be infinity, like so. F of t dt, now press enter. Well, first of all, let me just change it to radian. Now, we don't want an exact value, we want a decimal value, so press control enter and it will give you the probability. 0.2048, right? Let's do this one now. So find probability that t is greater than 7 given that t is greater than 3. Okay, so probability that t is greater than 7, greater than or equal to 7 given that t is greater than 3 is going to be probability of t greater than or equal to 7 intersection t is greater than 3 divided by probability of t is greater than 3. T is greater than 3 is going to be starting from here, and t is greater than or equals to 7 is going to be here, and you have to find the intersecting portion. So intersection of these two starts over here, so we can say that this is just going to be probability of t greater than or equal to 7 or probability of t greater than 3. Okay, alright, very good. So we just have to calculate that. Let's calculate using cas. So probability of t greater than equal to 7 is going to be from 7 to infinity 2 over pi t squared plus 1 dt, which is equals to, let's do it on cas. Okay, now let's find the probability that t is going to be greater than or equal to 7. So press menu for 3, and now 7 all the way to infinity, f of t dt. Press control enter, and there you go, that's how you do it. 0.0903, and we already calculated probability that t is greater than 3. Again, these two, the sign doesn't matter, as I went through earlier. It's going to be the same exact thing. So probability of t greater than 3 is equals to probability of t is greater than or equal to 3, which is going to be 0.2048. So let's divide it. So 0.0903 or 0.2048. Dividing this on cas, and you will get 0.4410. Alright, fantastic. Okay, so our answer to this question is going to be 0.4410. Alright, let's move on to the next question. Given that probability of t less than q is equals to 0.69, find the value of q. Okay, let's construct the integral for this. So it's going to be from lower bound. What is our lower bound? Well, we just have to look at our domain. So our lower bound is t is greater than 0, so that's our domain. So our lower bound is obviously going to be 0. So 0 to q, 2 over pi t squared plus 1 dt equals to 0.69. Now let's solve with this on cas. Alright, so let's now find the value of q. So what you do is press menu 3 menu for 3. Our lower terminal is just going to be 0, and upper terminal is going to be q. F of t dt equals to 0.69 comma q. Press control enter, and there you go, that's how we do this. So our cas gave us q equals to 1.889. Round off. Okay, very good. Okay, this is horrible looking thing, but do not worry, I got you. Let x be a random continuous variable for our probability density function f. Okay, so find value of a such that probability of x less than a is 0.5. So again, I'm just going to use cas for this. No way I do this by hand. So 0 to a, we're just constructing the integral f of x dx, and let's do this equals to 0.5. Let's do this on CAS now. Now, in some scenarios, CAS calculator might choke up. So what I really recommend you to do is to define the the piecewise function individually. So we had this cosine function and a massive linear equation. So what I'm gonna do is, rather than defining all of them together in piecewise function, I'm going to define them individually first. So like I'm going to say menu 1 define g of x equals to cosine of x, and again I'm going to press menu 1. Now h of x is equals to the massive linear function. Just give me like 25 years to type it. Alright, now we have both of these functions defined. Now why did I choose to do them individually? Is because say that your CAS calculator cannot calculate the probability when you just set the whole piecewise function equal to something. In that case, you can also do this question individually. I'll show you how, but now I'm just going to define the piecewise function as well. So menu 1 f of x. I'm going to show you both ways by using just directly f of x and setting it equal to 0.5, and we are also going to do it individually so that you have the idea of how to tackle these sort of questions in case if your CAS decides to choke up. Now equals to, now let's again navigate yourself to this button over here, press that. Now say that if you want to define more than two piecewise function, how would you do that? Well, you just press this one over here, press that, and now it will ask you how many piecewise function you have. But in this case, again, it's just going to be 2, but this is just for your reference, that in case if you have to define more than 2, you can still do that. Press OK. Now we can just type g of x, and now let's type the domain. It's going to be 0 to pi on 4, so 0. Now h of x, and its domain, so pi on 4 to this massive square root we had. So now we can, oh, this one is exclusive, not inclusive. Okay, there we go. Now we define our function. Now press enter, and now we have a piecewise function defined as well. So let's try by just using piecewise function first, because well, it's the most quickest way. So press menu 1, menu 3, 0 all the way to a, f of x dx is equals to 0.5 comma a. Press enter, control enter, and it will give you the value of a. Now say that if your CAS decides to choke up and it takes forever, well, what you can do is you can make use of this individual function that we define over here, like g of x and h of x, to calculate this. So we have to first find the area under the cosine graph and see if it exceeds 0.5 or not. So let's do that. Menu 3, 0 to pi on 4, that's our terminal, so pi over 4, and we define that as g of x. Press dx, press control enter, and as you can see, this area already exceeds 0.5. So we know that our a is going to be between 0 and pi on 4, because we want probability equals to 0.5, and calculating probability just under the cosine function gives us 0.707. So we can easily know that our a value is going to be between 0 and pi on 4. Alright, so what you do is press menu 1, menu 3, and now our lower terminal is going to be 0, upper one is going to be a, and now g of x dx equals to 0.5. Now the only reason I know that it's going to be between 0 and pi on 4 is because cosine function, when integrated between 0 and pi on 4, gives us a value that is greater than 0.5. So I know that a has to be between 0 and pi on 4. So let's put that restriction on a, only because this is a trigonometric function. If we didn't put the restrictions, what it will do is give us a general solution for a, which is not what we want. So let's put the restriction. So press Ctrl Enter, and there you go. It still gives you the same value. Now what would happen if this value was less than 0.5? How would we do it then? Well, what you would do is first find the value. So let's say that this was 0.35, say. Then what you would do is use our h of x function over here, because if cosine function when integrated between 0 and pi on 4 gives you 0.35, just suppose, then the remaining area would be under this function over here, and the remaining area would just be what? 0.15. So say that our cosine function had 0.35 as the area when we integrated. So what would you do? next? Well, first we would say 0.5, 0 minus 0.35. So this is the remaining area that h of x function would have. So let's do that now. So menu 3 1, menu 4 3, now 0 to a, h of x dx equals to 0.15, and then you can just find the value of a. So if your value was less than 0.5, so we got a equals to 0.5236. That's good. Find the value of b such that probability of x is greater than b is equal to 0.8. So what's going to be our integral now? So b is going to be our lower bound now, because we want, b. So this is our function. Let's say this is our function, and say that our b is going to be here. So we want, this area to be 0.8, and of course we know that one endpoint is going to be b, and b is going to be the lower terminal, and this is going to be our terminal, the upper terminal. So our upper terminal is going to be this, because this is where exactly the function ends. So let me just write that real quick. F of x dx is going to be 0.8. So again, let's do this on CAS. Alright, so let's now find the value of b. So we already have our integral set up. So menu 3 1, menu 4 3. Now our lower terminal is going to be b this time. The upper terminal is going to be the maximum value of the domain, so it's just going to be the massive surd that we have over here. So what I'm going to do is just copy and paste this, Control C, Control V, and now f of x dx equals to 0.8 comma b. Press Control Enter, and yeah, there you go. That's how you find the value of b. So our CAS gave us b equals to 0.2014. Find the value of c such that probability of x is less than c is 0.75. Pretty easy now, right? So what is our lower terminal? 0. What is our upper terminal? C. F of x dx is going to be 0.75. So if we do this on CAS, let's do it now. Okay, again, for value of c, it's going to be the same thing. So menu 3 1, menu 4 3, it's going to be between 0 and c. F of x dx equals to 0.75 comma c. Press enter, and yeah, there you go. That's how you find the value of c. So as you can see, c is going to be 0.8485. Brilliant. We're done with this question, I think. Yep. Alright, so let's move on to mean, median, mode, standard deviation, and all that. Okay, let's do that. So the value median, so it's the value where probability is exactly equals to 0.5. Okay, what I mean by this, so say that you have, your Bell distribution over here, and we know that, if we divide it into two parts, this area is going to be 0.5, and this area is going to be 0.5. So this right over here, this value, the value on the x-axis, is going to be our median. So that's the graphical representation of median. So it's going to be 0.5 here and 0.5 here. So that's the graphical representation of median. Okay. In other words, we can also say that this is the 50th percentile. Alright. Let x be the continuous random variable in a probability density function f. So this is the integral that you use to calculate the median. As I just explained, that this doesn't have to be necessarily just negative infinity. Say that your function has a domain of 0, less than x less than 1. In that case, if you were to calculate median of that function, this would be 0 instead of negative infinity, and this would still be m, because we are finding that x value at which the area under the graph is exactly 0.5 either side. Okay, so just keep a note of that this is not always negative infinity, but it's going to be your lower terminal, so always be on the lookout for the domain. Okay. Mean is the average of the continuous random dataset. That's literally it. Okay, and mean is going to be e of h of x, and mean has this integral over here. Now, doesn't that look familiar with discrete probability? It does, right? Because in discrete probability, we learned that to calculate mean, we have to do x times probability of x equals to x, right? It's the same here. We are adding thin slices of rectangles up, and that's going to be our integral over here, and it's going to be exactly the same formula. except rather than having, you know, literal PMF like probability mass function, we have like a function and we have to work with area under the graph, so they just change it to f of x. Other than that, the formula in discrete probability that we learned for calculating mean is exactly the same as continuous random variable. Okay, so say that you have to calculate e of x, right? The integral for that would be your lower bound a, upper bound b, and it's going to be x times f of x. Now what happens if you were to calculate e of x squared? You have to do squared here, and so on and so forth. Now one more thing, the linear transformation that I discussed in discrete probability video are still valid in this. So if you were to calculate e of 2x plus 3, you can either do this, so 2x plus 3 times f of x dx. Now of course your lower bound and upper bound, so a and b, lower terminal, upper terminal, a and b. You can either do that, or you can also say 2 times e of x plus 3. It does not matter. Whichever one you find easier, you should do that. Now, most of these questions are going to be done on calculator anyways. There's not many things that they can ask in continuous random variable in exam 1, apart from giving you, you know, like questions with simple numbers. Of course, they of course want to test you the, you know, the concept. So they will ask you continuous random variable, but it's just going to be with simple numbers. They're not going to give you many messy things unless they are in a very bad mood and it's going to be a really hard exam. But yeah, keep that in mind, that linear transformation for, you know, mean, variance, standard deviation, all of that which we discussed in discrete are still valid in continuous probability. Okay, let's move on. Now mode. Mode is again the most repeated value in the continuous random dataset. So a graphical representation of mode could be what? Say that we have a graph here, so it's going to be like a quadratic and then a linear going down. Our mode is going to be this value over here. Why? Because it has a peak and it has the highest chances of occurring. So this x value over here, this is going to be our mode. Okay? Variance again determines the spread of the data, and these are all the formulas to calculate variance. Now this is exactly the same as discrete probability. This part over here, exactly the same. Now this again, you know, as I mentioned earlier, that this is just related to like linear transformation. If you want to, you can use them in continuous as well. If not, you just have to chuck in the function that they ask, you know, you to find. Like if the h of x is just going to be, you know, 2x plus 3, yep, just chuck that in as h of x and go on from there. Now again, generally we are going to be using this integral quite a lot in the exam as well as SAC and everything. So this is going to be like, you know, the most used formula to calculate variance, as I already mentioned in the discrete probability video. Okay, so let me explain you real quick. So this is going to be your integral. So we are calculating e of x squared first. Now again, e of h of x is going to be integral from a to b, where a and b are your terminals, h of x times f of x. But here our h of x is going to be x squared, so the integral will have x squared. Now here we are just calculating, you know, the mean and then squaring the whole thing. So e of x, our h of x in this case is just going to be x, so there is an x over here. Now again, the terminals of this integral can vary depending on the domain of the function, so be always on the lookout. It does not have to be from negative infinity to positive infinity all the time. It's just so that I can give you a rough idea as to what it is. But if your function again is from 0 less than x less than 1, so this is your domain of your function, then our lower bound will be 0 and upper bound will be 1. So please again be on the lookout for that. Don't just write negative infinity and positive infinity just because I wrote that. Okay, it has to be your terminals or the domain that is given. Alright, so standard deviation again is just square root of variance. Yep, pretty easy, pretty well known. You know, you should know it by now. Discrete and continuous, almost same thing. So yep. Alright, the amount of time RAM spent studying math methods can be modeled by probability density function, where t is a continuous random variable. To represent the amount of time, maybe in hours. I forgot to write the unit over here. In hours, okay, that RAM spent studying. Alright, find the median time RAM spent studying math methods. Okay, no problem. So in median time, again, what's our integral? it's going to be from our lower terminal to upper one. Now what's our lower terminal over here? It's just going to be 0, and upper one is going to be what? M. Okay, so it's going to be f of t dt equals to 0.5. Let's use CAS to solve this. Alright, so let's start off by defining our function again. Alright, so we have to find the median. So it's going to be menu 3, 1, menu 4, 3, 0 to m f of t dt equals to 0.5 comma m. Press Ctrl Enter, and there you go, that's your median. So our m is going to be 0.6931. Find the expected time Ram spent studying maths methods. Expected time, what does the word expected mean? Yeah, it literally means mean. Whenever you see expected value, it's going to be the same as finding e of x or mean of the function. Okay, so don't freak out. So expected time is just going to be e of t, which is going to be from 0 all the way to what? What's our upper terminal? It says t is greater than or equal to 0. So it goes all the way to positive infinity, correct. So it's just going to be infinity t times f of t dt. And if you evaluate this on CAS, let's do it now. Now we have to find the value of mean, so press menu 4, 3. Lower terminal is just going to be 0, upper one is going to be positive infinity, and t times f of t dt. Press Ctrl Enter again, and you'll get a mean value of 1. You're going to get 1 hour. So you always must write the unit. So e of t, that also represents the mean time that Ram spent studying. Mean time. Now time has a unit in this question, so never forget to write your unit. Okay? Find the variance. Variance again. What's our formula? So variance is equal to e of t squared minus mean squared. So e of t squared is going to be 0 to infinity t squared times f of t dt. Now if you were to evaluate this on CAS, now let's do it. Okay, now variance, so we already have the mean, so now we have to find the e of t squared, so we just have to replace this by t squared. Press Ctrl Enter, and there you go. So this will give you 2. Now what's our unit? Hours squared. Why is it hours squared? Well, here as you can see, time is squared, so it's going to be squared. The result that we get is going to be squared. Now what is our mean? So we already calculated mean above, so we just have to square it. Our mean was just 1 hour, so 1 squared is just going to be obviously 1. Again, don't forget to write your unit. It's going to be hours squared. Why? Because if you were to square hours, our time unit is hours. Square that and you'll get hours squared. Okay? Alright. Now we take that away, so it's going to be variance is going to be just applying this formula over here. So what is our e of t squared? It's going to be 2 minus 1, which is going to be 1 hour squared. Do not forget your unit, they will cut mark off. Now standard deviation again. Standard deviation is just square root of variance, and in this case square root of 1, which is just going to be 1 hour. 1 hour. Okay? Now why is it hour and why not hour squared? Because if you were to square root hour squared, you'll get hour, right? Not squared. So same thing, same logic. Okay. Quartiles. Now these are, not explicitly mentioned in maths methods, but if you are doing, statistic maths like further maths, you'll learn something about this as well. So, and these are pretty, maybe if in an unlikely event they ask you find the upper quartile of this, of this function, you know what it means. So okay, so let's just go over it briefly. So lower quartile, well, it's going to be an integral from a, not again, it doesn't have to be negative infinity, it could be your endpoint. It must be your endpoint, the endpoint that they give you. It should be based on your domain. Okay, just don't put negative infinity for the sake of it just because I put it. No, read the question, look at the domain, and make your integral accordingly. Alright, so it's going to be from, let's say, a all the way to q1. So let me graphically represent this. So let's say you have your graph over here, and for lower quartile, the area of the graph must be 0.25. So this must be 0.25. If this was 0.25, then this will be our lower quartile. So that's what lower quartile is. Now, what would be the construction? What would the integral of this? So it would just be from 0, because it started from origin, 0 to q1 f of x dx equals to 0.25. So this is the integral, constructed based on the information given. Now that's our q1 done and dusted. Median, we already learnt it. Again, could be any endpoint that you get in your question. Just check your terminals, don't put negative infinity. Upper quartile is when the area is 0.75. So again, if I had this same quadratic drawn over here and say that the area over here is 0.75, then this will be our upper quartile. Okay, so again, if I were to do an integral construction based on this, it will be from integral from 0 to q3 f of x dx equals to 0.75. Now solving for q3 will give you your upper quartile. Interquartile range is just simply q3 minus q1, as you can see here. So these are all just like generic formulas that are already there on the internet, so you can find them anywhere. Alright, question 6. Let x be the random continuous variable for the probability density function f, and this is your probability density function right here. And what we have to do is to find probability that x is less than a. Find a such that probability of x less than a is going to be 0.25. So our integral that is going to be constructed from this is going to be from, what is our endpoint? It's going to be 0, because that's where our function starts. So 0 all the way to a, f of x dx equals to 0.25. And if you were to solve this on CAS for value of a, you will get a equals to 0.4563. If you're still unsure of how to do it on CAS, how to solve this on CAS, just rewind my video. I've shown you a couple of examples of how to do this on CAS if you're still unclear. Okay, find the value of b such that probability of x is less than b is equal to 0.75. So integral from 0 to b f of x dx is going to be equal to 0.75. Now again, solving this on CAS would give you b equals to 0.7570. Hence, find the IQR. What is IQR? IQR equals to q3 minus q1. Do we have that already? I'm pretty sure we do, right? What is our upper quartile when area is 0.75? We have already found it here. And what's our lower quartile? 0.25, which also we have found here, right? So we just have to do q3 minus q1, so b minus a, which is going to be b minus a, it's just going to be 0.7570 minus 0.4563, which is going to be equals to 0.30007. Oh, sorry, a bit too many zeros, so it's 0.3007, and that's going to be your answer. Okay, final exam style question. The amount of time Arnav plays chess every day is modeled by probability density function c of t, where t is the random continuous variable to represent the amount of time in hours Arnav spends playing chess every day. Oh god, he must be cooked by the time he finishes playing chess. Anyway, find the value of k. Yeah, you know what? I think I might have something with k. I love variable k. I always put it everywhere. I know. Anyway, okay, that's beside the point. Alright, let's focus on the question. So, let's just draw a rough graph of this. It's always good to graph when you're not understanding what to do, because, just find the value of k. It's not like k is over here or anything that, we know what to do, but it could be pretty challenging. So, whenever you're confused, when in doubt, just pull your graph out. Okay, take that. Alright, so 0.25 t squared is just approximately going to look like this, and this is just a linear line, so it's just going to look like that. So that's that. Now, what are our coordinates? So this coordinate over here is going to be 1, 0.25, and that's pretty much all we know. So this is going to be 1. Alright, now how do I find the value of k? Now, there are going to be some assumptions that we're going to make. I mean, not assumptions, but using the law of probability density function that we discussed at the very beginning, we are going to make some conclusions. Now, k. What do you think k would be? K would be most likely an x-intercept, right? X-intercept or a value that will give you a positive area, not a negative area, and that's why my graph stopped here. I didn't let my graph go down here because here is negative area. Okay, so k is most likely to be somewhere between these 2 points over here. Okay, so just keeping that in mind. Now, what are other things that we know about probability density function? The area of probability density function, the area under the graph of probability density function must always equal to 1. Now, how do I find the area though? Well, how do we do this? Okay, let's find the area that is underneath here, because this is the component of this parabola. We already know the domain of this parabola. So 0 to 1, 0.25 t squared dt is going to equals to, if you do it on CAS, you'll get 1 on 12. Now, what does this say? This says that this remaining area over here is just going to be what? It's just going to be what? 11 on 12, right? Because the area must add up to 1, so this area over here must be 11 on 12. Now, what else do you see about this? Can you see that this is a triangle? Right? This is clearly a triangle. We know the height of this triangle as well. It's just going to be 0.25. We know the base of this as well. It's just going to be, this is going to be k. Let's say this, let's call this as k. Now this is going to be k minus 1. This base over here is going to be k minus 1. Right? So the rest of the part is pretty easy. Half times base, which is k minus 1, times the height, which is 0.25, which is equals to 11 on 12. And if we solve for k using CAS, we will get k equals to 25 on 3. And do we end it here? No. Why? We are forgetting the units, because k is a domain, and the domain is based on time. So our units is going to be hours, because time has units. So just write your damn units. Hence, find the maximum amount of time Arnav can possibly play chess in one day. Okay, now, is the answer in front of us? Well, yes, it really is in front of us. How so? Well, look at the domain, right? The domain is what? Domain of this function is basically representing time. And this k value over here that we found is the maximum value of this domain, correct? So meaning that k is the time, or k is the amount of time, the maximum amount of time that Arnav is going to play chess for during a day, right? So it's going to be 25 on 3 hours. So read the question carefully. This is, based somewhat from the actual exams, where they, ask you questions like part B over here, where you've already done all your hard work, but they're testing you if you know what you found. Like here, we just found a value of k. Now what does k represent? We don't know. If you didn't know what k represents, you wouldn't be able to do this question, right? So please always try to understand what the variable is representing, because if you don't know what variable is representing, you cannot solve those, very difficult 1-mark questions that you can always ask, and the answer and the correct answer rate of those kind of questions is always like what? Between 0 and 5%. Yeah. So if you want to be out there, flex on them, haters, just know what you're doing, just know what a variable is meant for. Okay? Calculate the probability that Arnav play chess for 2 hours a day. So probability that Arnav play chess for 2 hours a day, can we calculate that? We possibly could. It's just going to be 2 to 2 f of t dt, which is just going to be 0. Okay, this is for continuous probability. It's just going to be 0. Alright? Okay. It is known that Arnav played chess for less than 3 hours on a particular day. What is the probability that he at least played for 1 hour? Okay. probability that he played for at least 1 hour, given that he plays less than 3 hours. This is the hardest part done. Okay, and now this is just going to equals to 1 probability of 1 less than or equals to t less than 3 divided by probability of t less than 3, and probability of 1 less than t less than or equals to t less than 3 is just going to be integral from 1 to 3 f of t dt, which is going to be equal to 19 on 44, and probability of t less than 3 is going to be from what's our terminals. Let's look at the domain. Our lowest value is going to be 0, so our lower bound is 0, and upper bound is going to be 3 because from here, so 3 f of t dt is just going to be 17 on 33. So 19 on 44 divided by 17 on 33. Simplifying this on CAS will give you 57 on 68. Alright, what is the expected time every day that Arnav spends playing chess? So E of t equals to 0 to what's our upper bound? Upper bound is going to be our maximum, the last value of the domain, and it's going to be the value of k, which we found to be 25 on 3. T times f of t dt. Again, this t over here is the same as the t inside this bracket. If this was t squared, this would be t squared, so on and so forth. So just remember that. And this will give you an answer of 3.220 hours. Okay? Alright. Calculate the variance and standard deviation. Okay, variance is going to be equals to e of t squared minus e of t whole square, so mean squared. So e of t squared is just going to be from 0 to 25 on 3 t squared times ft dt, and you will get an answer of 13.664 hours. And what's our unit? Hours squared, because t is squared over here and t is time in hours, so t squared is going to be hours squared. Now mean squared, we already have calculated the mean, so 3.220 squared, that is going to be 3.2924 hours squared. Now if we were to subtract them, so e of t squared, so if we were to subtract them, so 13.664 minus 3.2924, we get an answer of 10.3716. Now calculate the standard deviation as well. So this is just going to be our variance. Standard deviation is going to be square root of variance 3716, so let's square root that, and you will get 3.221 hours. Okay, so that's how we do this, and find the median time Arnav spends playing chess. Okay, this should be pretty simple. What's our lower bound? It's going to be 0. Upper is just going to be m because we are finding the median. F of t dt equals to 0.5. Now solving this on CAS would give you m equals to 2.917 hours. What is the ideal amount of time Arnav plays chess in one day? What do you mean by ideal? Ideal amount of time meaning, mode. It's kind of like mode. So let's find the mode. What do you think is going to be mode, right? Again, let's draw the graph over here. So it's going to be like that, and a linear line. Now you can see our mode is just simply going to be this value over here, right? We know this coordinate is this coordinate is 1, 0.25, and this is just going to be 1. So our mode is going to be what? T equals 1 is just going to be our mode. So the ideal amount of time he plays chess for is 1 hour. Okay, 1 hour. Alright, and that's it for your continuous probability. Now I hope that you learned a lot from this. If you did, that's great, and I will hopefully see you in the next video. Bye bye.